had a really good week. Today we're going to look at more geometry, but this time we're going to look more specifically into angles. So hopefully you guys remember what angles are, because yeah, we'll be covering that today. Here's a review if you got what they were. Basically, an angle is just a measurement of the space between two rays. We also call them edges, but they're usually called rays just because they form an angle. So it's a measurement of space between two sides intersecting at a vertex. And an angle is usually measured in degrees. So it's just like a superscript, or you can call it like exponent 0. But it's not exponent 0, of course. It's just a symbol. Usually the value is between 0 degrees and 360 degrees, where in 360 degrees is just a full rotation, right? You're going a full circle all the way back. That's 360 degrees. I forgot to put parentheses right here. And then remember that the syntax for an angle is just it's pretty straightforward. It's just an angle, and then we covered this last week. So like you say you have angle ABC is just the angle at vertex B, and it's marked between A and C. So the vertex is at B, that's where the angle is, and it's between two other points A and C. So that's how you read that. That's how you interpret this symbol. Any questions about this before we move on? No questions. Right. Let's go on to some types of angles. Right. So here I have 6 types are marked. So the first one is an acute angle. Acute angles are angles that are between 0 degrees and 9 degrees, but not 0 or 90. So it can't be inclusive. Can't include 0 or 90. Obtuse is an angle between 9 degrees and 108 degrees, but it can't be either one of those values. And a reflex angle. Reflex angle is just an angle between 108 degrees and 360 degrees. And so here's I'll also provide like a diagram just to make that more clear. And you can see acute here is less between 0 and 90. Obtuse is right here between 90 and 180. And you have a reflex angle that goes beyond the 180, but it's still less than the 360 degrees. Oops. And then you have some other special angles. So you have the right angle. Right angle is an angle that's exactly 90 degrees. So right here. And you also have a straight angle. Straight angles is just a straight line, very straightforward. This is exactly 180 degrees, stuff like that. And we have 360 degrees. This we can call a first full circle or full rotation. So that's how we can refer to 360 degrees. I'm not showing here, but 360 degrees is a full circle, just like that. Any questions about this? Right, hopefully you guys understood the types of angles there are. I think next slide's a problem. So identify the following angles as acute, obtuse, reflex, or neither. So it should be fairly straightforward. Can someone give me an answer for question 1? What angle is that? So out of these 4 options. Anyone have an answer for question 1? So, yeah, acute angle. Oh, Bob said too. Okay, good. Yeah, between 0 and 9 degrees. So this is an acute angle. How about question 2? Not obtuse. No. So let's look back. Remember these definitions. So what should it be? Yeah, reflex. So it's bigger, larger than 180 degrees, but smaller than 360 degrees. So it's reflex. How about question 3? Oh, and the principle's here. Third question, yeah, obtuse. Right, between 9 degrees and 108 degrees. And, I think we have a new student. 哎，金老师好，是不是来个新学生？Think we have a new student. OK，我也没听说。啊，对，哦，你给错 link 了，是不是？哦，OK，嗯，对，嗯嗯，没事没事。All right, I'm glad that's settled. So I guess they were great for students. Okay, let's go back. Question 4. So 180 degrees. How would you classify that? Yeah, neither. It's just a straight angle, right? So it can't be obtuse. You can't have exactly 180 degrees for obtuse. You also can't have exactly 180 degrees for reflex. So we just refer to it as a straight angle, or you can call it neither as final answer. All right, let's move on. These problems are pretty simple. Let's go some more advanced topics. So we're going to the next part. We'll be focusing on a concept called angle chasing, right? So angle chasing, it's basically the technique that you use to determine unknown angles. And then here's some techniques that you use. So first concept you have is complementary angles. So these are just angles that add up to 90 degrees. So here's a diagram. You have 60 degrees plus 30 degrees. That adds up to a right angle. And so these are considered complementary angles, right? Next technique is called supplementary angles. So these are angles that add up to 180 degrees or straight. You just make up a straight line. So here you have 120 degrees plus 60 degrees gives you 180 degrees. So these are called supplementary angles. And finally, we have opposite angles. So opposite angles is just angles that are on opposite sides of like two intersecting lines, and they are congruent. So in this diagram right here, we have angle A would be equal to angle B, and because they are opposite angles. Right? Any questions about these? This might be reviewed for some of you. Right? Nothing in chat. All right, let's move on. Okay. I remember we covered parallel lines last week, but I think today let's just review them as well, because we'll be using them in some problems later on as well. So remember, parallel lines are just lines that don't intersect each other. They never intersect each other. And then there are some like very interesting properties that you can get with angles when you cross a transversal line in between two parallel lines. So in these diagrams, the parallel lines are marked with these arrows, right? These arrows right here, indicating these two lines are parallel, and then the line that crosses between them is called the transversal line. And so, yeah, you have some very interesting properties. We're going to look at 4. Remember, one of them is corresponding angles. So here you kind of have like an F formed. So you have like this part of the parallel line, this part of the parallel line, and then you have this part of the transversal. And you see where the angles are located. They're kind of like, I don't know, vertically opposite. So this angle here would be equal to this angle over here. So this is what corresponding angles is, right? And then let's go down here. This concept's called alternate interior angles. So basically you have angle on one side and then an angle on the other side of a transversal. So say you have one on the top left, then you have one on the bottom. Then the alternate angle would be on the bottom right. And say you have one on the top right, the alternate interior angle would be on the bottom left. Right? So here we have 1 would be equal to 2, angle 1 equals angle 2, and here we have angle 3 would equal angle 4. And the way you can memorize this is that you just form a Z pattern. So follow where my cursor is moving. So you go over here, move along that, and then move on transversal, and then go on to the other parallel line. So you form a Z like that. Or the other way as well for that. And then whichever angles are formed inside the Z, form your alternate interior angles. And then we also have alternate exterior angles, but you see this less often. So instead of like directly inside the in between the two parallel lines, now they're outside the parallel lines. So but you still have them congruent to each other. So you have angle 1 equal to angle 2 over here, angle 3 equal to angle 4 over here. Yeah, you can basically prove alternate exterior angles using alternate interior angles and opposite angles as well. So basically, you're putting like say 1 over here, and then its opposite angle would be up here. And similar thing for angle 2. Angle 2's opposite angle will be over here. And then angles 2 would still be equal to angle 1. So that. All right, and then the final concept. It's called co-interior angles. So it's like you're forming a C. So you're going in one direction with one parallel line, then you're going onto the transversal, and then now you're moving into the opposite direction of the other on the other parallel line. And then whatever angles are formed in between that C shape, they add up to 180 degrees. So this plus this equals 180. Yeah. All right, so these are the properties you can make with parallel lines and transversals. Any questions about these? Yeah, these are very important. So hopefully you get a good grasp on these concepts. No questions? All right, hopefully you guys understood all that. Okay, let's see what's next. Okay, it's a problem involving parallel lines. So in the diagram below, we have A prime. So it's not like A apostrophe order. We call this A prime. A prime right here. A prime and C prime are parallel lines. So assume they're parallel lines. Assume that the angle A prime AB, so over here, they call it W, but say it's 135 degrees. And angle C prime CB, so angle Z over here, is equal to 116 degrees. Find the value of X. I'll give you guys a minute to think about this. Yeah, X is the angle right here, so we call it ABC. And here's a hint, you're gonna have to draw another line to help you out. Okay. Just curious, does anyone have an answer so far? No, not quite. Yeah, I think it's a pretty challenging problem that I picked. So I think we'll take it up together. 109 says Chengao. I think that's correct. Yeah. Nice. Let's take it up. So I have time to look at the question. All right. Let's draw our parallel lines. Let's do this quickly. All right, there you go. So this was 135. This angle right here is 116. We're trying to. Oh, did I stop sharing? Okay. Sorry about that. Sorry about that, guys. It's a glitch probably. Okay. I guess I'll share my entire screen or something. Just give me a sec. Apologies. Here you go. All right, can you guys see it now? Or no? Right. Can you guys see my screen? Say yes if you can. Okay, Eric nods, so it's good. Okay, so this is the diagram that they had. So remember, it's two parallel lines, and then you have like two lines in here. Here you have 135 degrees. This angle is 116 degrees, and you're trying to figure out this angle, called it x, right? And so, does anyone know what we should do? So I hinted that we should draw like a helping line. So what line should we draw? Where should we draw another line? Someone tell me. I know Chen Gao, you solved it, so tell me how you solved it. Mm, perpendicular, like this. Um, I don't see how that works. Actually, here. Oh, I see what you mean. Okay, okay. But okay, I was thinking of something different. Here you drop another line that's parallel. Actually, you draw a line that's parallel to both these lines, and you draw it through this vertice right here. So all three of these lines are parallel. And the reason why we do that is we can use the co-interior angles. I think it was called co-interior, right? Let me check. Yeah, co-interior angles, right? Remember, we have this angle and then we have this angle. So 135 degrees, and then this angle, let's call this one Y, 160 degrees, and let's call this one Z. So Z and 160 degrees are co-interior, Y and 135 degrees are co-interior. And remember that co-interior angles add up to 180 degrees. My handwriting is awful today. All right, so we have Y plus 135 is 180. Z plus 116 equals 180. All right, so and then if you solve for this, you get Y equal to 45. Z would equal 64. And so now if you're trying to solve for the value of x, so x was just this entire angle, it's just a sum of y and z. So x is just y plus z. And I'll just write the final answer. So 45 plus 64 is 109. Right, there you go. So final answer is 109 degrees for x. Right. Any questions? All right, there are no questions. Let's move on. Okay, what's next? Oh, there's another problem. Okay, here you go. So use parallel line properties to prove that the angles in a triangle add up to 180 degrees. And use this diagram right here. So I'll let you guys think about it for a sec before I cover the proof. Right. I think I'll take this up. Maybe the diagram is a little bit confusing for you guys. So here's the diagram. So you have a line up here, then you have a triangle, and the base of the triangle is actually parallel. So in the diagram it didn't mention that, but the base of this triangle should be parallel to the line up here. So I'll extend this then, just to show that. So it's parallel with this, right? So we have 1, 2, 3, 4, and 5. Right? So what we're trying to prove is that 1 plus 2 plus 3, so angle 1 plus angle 2 plus angle 3, that's what they call it in the diagram, that's equal to 180 degrees. Right? So we're trying to prove this using parallel line properties. So what we notice is that we also have angles 4 and 5, right? We want to do something with those, obviously. What we also note is that 4 plus 3 plus 5, so angle 4, plus angle 3, plus angle 5 is 180 degrees. Like, that doesn't need to be proven, because this is a straight line. We don't need to prove, well, yeah, we don't need to prove that these are supplementary angles, because they form a straight line. So this is obviously 180 degrees. Right? And so now we have to compare some of the angles. So what you notice is that, I think I'll use a different color. Say like yellow. All right. So what you can do is form a Z pattern. Oh, that looks weird, but oh, that's clear. No, that didn't work. All right, just right here. So I'm writing a Z. So this Z right here from connecting the angle 4 and then angle 1. Let me try again. Hopefully it doesn't like glitch out. Right, this is the Z I was thinking about. So here we have angle 4 that's enclosed, and then on the other side we have angle 1. And we know that these are alternate angles. And so what this means is that angle 1 is equal to angle 4 because of alternate angles. Similar thing for the other side. So here we have angle 5 and angle 2. And we know that these are also alternate angles. So they're equal to each other. So angle 2 is equal to angle 5. All right, so and then what you can do is you can substitute any of, so you have two equations right here. You have 4 plus 3 plus 5 is 180 degrees. You also have 1 plus 2 plus 3 is 180 degrees. You can substitute 4 into here and a 5 into here to prove that it's 180 degrees. Or you can also substitute 1 into here and then 2 into 2 for 5 right here. And that'll prove that the angles in the triangle add up to 180 degrees. So that's the proof. Any questions about this? Any questions? No questions? Okay, let's go back to the slideshow. So I have some things to cover. Right. So let's look at something called interior and exterior angles. Actually, we covered interior and exterior angles in these parallel lines, but let's see what they are more specifically with polygons. Right. So these are pretty straightforward concepts. So interior angles, these are angles that are inside a shape. So if you look at the diagram below, you have this triangle, and then the 30 degrees that's inside triangle, that's called interior angle. And then the angle over here, and the angle over here would also be interior angles. Right? Now the next, so exterior angles. These are angles outside a shape, but how are they formed? This is made by extending one of the side lengths of a polygon. So if you look at the diagram again, say we're extending the base of the triangle right here. We extend it all the way forward, like all here. And so the exterior angle would be measured between this extended side length and then one of the other side lengths of the triangle. So from here to here. This is your exterior angle for a triangle. And what you notice is that interior angles plus exterior angles, sorry, an interior angle plus its like paired exterior angle equals a straight line or 180 degrees. So it means the exterior angle would be 150 degrees as set in the diagram. Any questions about this before we move on? Wait, I'm assuming no questions. Okay, good. let's look at something called the exterior angle theorem. And this only applies to triangles, by the way. Right. So the value of a triangle's exterior angle, so this theorem states that the value of an exterior angle is equal to the sum of the two interior angles on the other side. So what do I mean by this? So let's take a look at a diagram here. What this means is that, so D is equal to A plus C. That's what the theorem states. So D is the exterior angle, and then the two interior angles on the opposite side, so not including B. So these are A and C. These are on the opposite side of D. So think about the two farthest angles away from the exterior angle, right? So D would be equal to A plus C. And it's fairly easy to prove why that is. Because so we have A plus B plus C is equal to 180 degrees, right? Because it's a triangle. And so then if you subtract B, you just get A plus C, right? But this is also equal to angle D because B and D are supplementary angles. They're on a straight line. So this means that angle D equals angle A plus angle C, right? So that's the exterior angles here. Any questions about this? The next slide is a problem on this here. So practice. No questions? All right, let's try this theorem out. Find the value of y. Sorry guys, my headset kind of stopped working for a second. Okay, I think it's good now. So in the problem here, find the value of y. Yeah, just find the value of y over here. And use the exterior angles theorem. Well, let's do it together then. Here are some pretty complex numbers. Can't draw straight lines. There you go. Whatever. Okay, so this is 5y plus 3. Four y plus 8. And 146 right here. And so what the exterior angles theorem would tell us is that 146 would be equal to 5y plus 3 plus 4y plus 8. So let's jot that down. I hope I have enough space. Just use a thinner pencil or whatever. Right, 4y plus 8 plus 5y plus 3 is 146. Okay, so let's move everything to one side and then let's combine them as well. Let's do that all in one step. So let's combine 4y and 5y to get 9y. Did not mean to write 4. Equals. So a plus 3 is just 11. 146 minus 11 would give you 135. Yeah, 135. And if you solve for this, so you just divide both sides by 9, you get y equal to 15. Okay, so put a degree symbol as well. Y equals 50 degrees. So that's how you get y. Right? Any questions about this? No questions? Okay, let's go on to some other topics. So you looked at, most of the shapes that we've been looking at, like from last week and also this week. Well, last week was always all about triangles. We also did a lot of triangles today, actually. But let's look at some other polygons, like squares, pentagons, and hexagons and stuff, right? So here's a term to know: a regular polygon. So regular polygon is just a polygon where all of its sides and angles are congruent. All right. So if say you're referring to like a regular triangle, the triangle has to be equilateral, right? Because all sides have to be congruent. So we're referring to like a regular regular quadrilateral. So quadrilateral is 4 sides. That means a regular quadrilateral is a square. That's the only side with all sides and angles congruent, right? I think you could also have never mind. Yeah, so it has to be a square. Speaking of a rhombus, but then the angles aren't congruent. So yeah. So basically, a polygon can be split into multiple triangles to determine the sum of its interior angles. So for example, with quadrilaterals, you can split them into two triangles if you just split by a diagonal. And here in the diagram, you can see some other examples. So you have a pentagon, and then you have a hexagon. So you can see that you can split a pentagon into 3 triangles, and you can also split a hexagon into 4 triangles, like so, right? So we're just only connecting them from once. So we're only picking like one anchor point, and then connecting it with all the other points. So that's how we form the triangles. You can definitely form more triangles, but we're only looking at from one anchor point, right? And so remember that a triangle's interior angles sum up to 180 degrees. And if we find a formula for how many triangles we can form for each kind of shape, so the number of triangles would equal to the number of sides minus 2. So for pentagon that has 5 sides, you would form 5 minus 2, or 3 triangles. So hexagon that has 6 sides, 6 minus 2, that would give you 4 triangles to make. And then so the formula for the sum of the interior angles of any polygon is just, so we have S is just the sum of the interior angles. This is equal to 180, so 180 from the sum of the triangle's interior angles, multiplied by n minus 2. So n minus 2 is the number of triangles we form, where n is the number of sides of the polygon, right? So this is a formula for the sum of all of the interior angles of a polygon, and it doesn't have to be regular. It doesn't have to be regular. Yeah, you can have irregular sides, and it'll still be the same formula for sum of the interior angles. But then say you're looking for one angle in a regular polygon. So remember, in a regular polygon, all angles are equal. So if you're looking for that value, you just take this sum, so 180 times n minus 2, and you just divide that by the number of sides or number of angles there. So you divide by n, and that'll give you the angle size in a regular polygon, any regular polygon, right? Any questions about these concepts? Okay, so if I didn't explain this part clearly, so why I said triangles, sorry, why this formula was the way it is. So if you see the diagram and in each of these diagrams, so remember that we form triangles with them. Notice that each of the angles in the triangles, they correspond to one of the interior angles of the entire polygon, right? So say looking at this bottom triangle right here, so you have this angle right here, this angle right here, and this angle right here. They belong to interior angles, and then you can so as you combine all the triangles, you can get one exact value of interior angle, and you also get the other values as well, right? So that's why you can do 180. So the sum of the interior angles times the number of triangles you can form, or n minus 2. So that's that formula explained. Any questions? Any questions? No. Nope. Just remember this formula. So this is the most important thing you should remember. Also try to remember how why the formula is formed like that. But let's move on. Now let's look at exterior angles of polygons. Right. So let's extend each of the sides of a polygon. So let's look at this diagram right here. So extend each of the sides of a polygon. So like so. A pair of interior and exterior angles are called linear pairs. So remember this, linear pairs. They just add up to 180 degrees. Very straightforward. So an example here, you have angle phi right here, add up, and then this angle right here has no name, but here I'm marking out. These would be linear pairs. Yeah, up to 180 degrees. And so now the sum of the exterior angles, so sum of 1 and 2 and 3 and 4 and 5 in this diagram, is the difference between the sum of the linear pairs. So this would be equal to 180 times n, right? So linear pairs add up to 180 degrees, and you just multiply that by the number of sides, n. We'll call n the number of sides from now on. So the sum of the exterior angles is difference between the sum of linear pairs and the sum of the interior angles. So 180 times n minus 2, as we got from the formula, as we got from the slide before. So this. So basically, you're just subtracting these two values to find the sum of the exterior angles. So you have 180 times n minus 180 times n minus 2. So we're subtracting these. We can expand the 180 times n minus 2. So we can get 180 times n minus 180 n plus 360 degrees. Notice that the 180 n's cancel out. And so what you're left with is 360 degrees. And so what this means is that the sum of exterior angles for any polygon is 360 degrees. No matter if it's a square, if it has like 10 sides, or if it's infinite size, like a circle. I don't know. The sum of the exterior angles for any polygon is 360 degrees. It's a constant. So it doesn't matter how many sides you have, right? Sorry, I think headset stopped working again. But any questions about this concept, this topic? All right, no questions? I think we have some problems after this. All right, so here's one problem. So what's the sum of all the interior angles in a hexagon? You guys are meant to figure it out yourself. So sum of interior angles for a hexagon. 6 sides, remember that. Does anyone have an answer for this? Yeah, that's correct. So basically, let's look at our formula. So remember, it's 180 times the number of sides minus 2, and minus 2. Yeah, so okay, it's just that. So 180 times 6 minus 2, right? 6 sides in a hexagon. So this is just 4 times 180. And if you solve for that, you get 720. 720 degrees. So that's the sum of all the interior angles in a hexagon. Any questions about this? Let me see what's next. So just a bunch of problems are left. Okay. I think we might end early today. Something never done before. Okay. Let's go on to the last, just 2 problems. Okay. Over here. What's the measure of angle x in the diagram below? Right here. Right. So it's a question. Give you guys a couple minutes to think about it. So this angle x. So Bob says 50 degrees. 50 degrees is correct. So let's see why. So is this pentagon? I'll just redraw it quickly. Right, I believe we had a 90-degree angle here. It's not scale, of course. This is 60 degrees. This angle right here is 90. Mark as a right angle. This is 70 degrees. And angle X is right here. So notice that the angles that are labeled or marked are exterior angles, right? They're on the outside of the pentagon. And they're formed with a side length that is extended. So these are exterior angles. And remember that the sum of the exterior angles in any polygon is 360 degrees. So basically we can just make like a simple equation where we add all these values up to get 360 degrees. So we have x plus 90. Guess we'll just go counterclockwise. So x plus 90 plus 60 plus 90 plus 70 gives you 360 degrees. Let's use this. So this means that x plus, so we have 90 plus 60 plus 90 plus 70. That should give you 310. Correct me if I'm wrong. Yeah, 310. Yeah, 310. This equals 360 degrees, right? And from here, just subtract 310 from both sides. Right? 360 minus 310 would give you 50 degrees. So that's the value of x. Right? Any questions about this? Okay, let's move on. Last problem. So yeah, it looks much more complex than the previous one. So here we have a circle with center C is drawn around triangle CQS, so C, Q, and S, such that Q and S, points Q and S, lie on the circumference of the circle. QC is extended to P on the circle. Chord PR, so PR, intersects CS, CS right here, at A and B, respectively. If QPR, so this angle right here is 24 degrees, and CAP is a right angle, determine the measure of angle X. Yeah, so we have X right here, X right here. I don't know why they marked both, but there you go. So I'll give you guys a few minutes to figure this out. Yeah. It's a bit tougher than I expected. Just curious, anyone have an answer so far? No, not yet. All right. I think you got that too. Yeah. Okay. Yeah, let's take this up then. See why it's 57. Okay. Yeah, well, let's just draw this out because why not? Like visualizing everything. Yeah, and these geometry problems, you should always like try to draw out the diagram on like paper or something. I cut out a little bit. Let's look at the diagram again. So we have this line. Pretend this is the center. I'm not going to label the points. It's a bit too tedious. Right? And I believe we have. Oh, shoot, that's ugly. Okay, let's try again. All right, so then we have this and this. Okay, I guess I'll label the angles. It's 24 degrees. Let's use a thinner pencil. It's 9 degrees. It's A. Angle B. Here's angle C. This is angle D. And we have X right here. They also labeled X over here. I don't know why. But yeah, you can see how they're equal because it's opposite angles. All right. See if I'm missing anything. Hopefully not. No. We're good. Okay. So we're trying to get angle X, which is like over here. And we have these values over here, 24 degrees, and then we have 9 degrees right here. So basically, we're trying to angle chase. So why it's called angle chasing. So you're trying to, move, like you're trying to get all these values. You're trying to go from here to here to here to here to here. You're chasing these angles until you get the value that you want. So why it's called angle chasing. All right. So let's start from, first look at this triangle right here. So we have 24 degrees, 9 degrees, and we have A. Right. So A is pretty straightforward to solve, because angles in triangle add to 180 degrees, so you just subtract whatever is already in there. So A would just be 108 degrees minus 90 degrees minus 24. So this would be 114. So 180 minus 114. That'll give you 66 for A. Right, so A is 66. Okay. Now what we can do is, let's look at A and B. These are supplementary angles because straight line. So that means B equals 180 minus A, which is 66, equals 114. Right, what you'll notice is that I could have just directly maybe not solve for A, directly skip that part, and directly go for B, because you can use the exterior angle theorem. So remember over here, exterior angle theorem. We have two interior angles on the opposite side of one exterior angle. So over here you have 24 and 90. These are the two farthest angles away from angle B. So I could have used the exterior angle theorem to get 114, which is just 90 plus 24. So remember 114. So look, I got 114 here, also 114 here. So no coincidence. Right? Now what else we can do is we can compare D with this right angle. These are opposite angles. Right? And you know that opposite angles are equal. So that D is equal to 90 degrees. Okay. Can someone tell me what the next step should be? I'll let you guys figure it out. What should be the next step? Here. So we have D is 9 degrees now. So what do you want to do next? B is 114. Someone tell me what we should do next. It's probably the hardest step in, yeah, it's probably the hardest step in this problem. But it's not too difficult if you think about it carefully. Yeah, perfect. Yeah, they didn't have to mark, they actually didn't have to mark this SE or this SE. I mean, they need at least one of them. The reason why is because, so remember looking at, so if you guys are a bit confused, we're looking at this triangle now. So I'll circle it up. So BCC, right here. So this triangle, right? So they labeled for you some of the angles, right? So you have B right here, and then you have two angles that are equal to each other. So you have C right here, C right here. This means that the triangle is isosceles. But when I say like they didn't have to mark one of the C's, so say I erased this one, didn't matter because this is the radius of a circle. This is also radius of a circle. So this length right here, that's the radius. This length right here, that's also radius. So then if you have two sides that are equal, you also have two angles that are equal. Right? That's a property of isosceles triangles. So I guess put C back in there. That's why it's two C's right there. So that means you have 2C plus B, which is 114, to get your 108 degrees. Switch back to the smaller pen. So I have 2C equal to, let's see, 180 minus 114. It should give you 66. C would be equal to 33 degrees. 33 degrees. All right. So this is 33. And this is also 33. Okay. And so now let's look at this smaller triangle right here. So this smaller triangle contains C, D, and X. So now we can solve for X. So we have X plus C plus D would give you 108 degrees. Where should I write that? Okay, bottom left corner. Plus C, which is 33, plus D, which is 9 degrees. Well, let's just do one step. So 2 steps. Sorry, X plus 123 will give you 108 degrees. It's 9 plus 33 gives you 123. And you solve for this, so subtract 123 from both sides, you get your final answer of 57 degrees. All right, there you go. That's that question solved. X is 57 degrees. Any questions about this before I end the lesson? Yeah. So my recording has 5 minutes left. It's the first time that we end early today. Quite nice.